Here we see some more units of concentration that may be useful in our calculations in this chapter. So the first unit for this video is the mole fraction, and it's abbreviated with this symbol chi here, this X. And if we're talking about moles of A here, our analytes, um, we find the mole fraction by dividing by total moles of all components in our sample. So we can make an example here, and we could have 1 mole of HCl, and we could have 9 moles of H2O in our solution, in our sample. Now, say we want to find the mole fraction for HCl. We would do 1 mole of HCl divided by 10 moles, right? The total moles of everything in our sample. So this is going to be a 0.10 mole fraction for this HCl. Then if we did the mole fraction for the solvent, note up here this kind of reminder that sometimes you are asked or need to find the mole fraction of your solvent and not your solute. So depending on what calculation you're doing, your mole fraction may change. But say we want to find the mole fraction for water here, we're going to now have 9 moles divided by 10 moles of solution or total, right? We can just say total down here because it maybe not as a solution. And we have the mole fraction here of 0.90. So again, depending on what you're referencing, your mole fraction will change, whether it's solute or solvent. And we would just define one as the lesser amount, that's going to be your solute, the solvent, the greater amount. So we have a second unit here, molarity, which you are probably already familiar with. It's abbreviated with this capital M, and it's the moles of solute divided by liters of solution. So liter is a measure of volume, and since volume is temperature dependent, molarity or concentration, right, can change with temperature then if it's reported in moles per liter. So we're going to see another example of a unit that doesn't change, but let's look at how we could calculate molarity. So if we want to solve for molarity and say we have 0.50 moles of, how about HCl again? And we have 0.25 liters, so 250 milliliters of solution. We divide 0.5 by 0.25, and we see that we have a 2 mole per liter solution, which we can say is 2 molar. So this last unit in this video we'll introduce here is called molality, and this is abbreviated with a lowercase m, so don't confuse it with molarity. Notice the L here, and it's lowercase, where the R in molarity is capitalized. Um, we have now moles of solute, that's the same as molarity, but on the bottom, notice we don't have a unit of volume. Now we have a measure of mass, kilograms of solvent. So this is only the solvent, not the total mass of the solution. So molality does not change with temperature. It is not called temperature dependent. So let's see if we can calculate molality of this solution here. So we're told that we have 36.5 grams of naphthalene, and we're given the molecular formula here for that. And then we have 425 grams of toluene. So to determine molality, we know that we need moles of solute divided by kilograms of solvent. So we need to determine who's our solute, who's our solvent. That is easy, whatever is present in a lesser amount, so the 36.5 grams. That's going to be our solute. So we have to convert grams to moles. And then kilograms of solvent will be on our denominator. So I already can convert to that quickly. If I have grams here of toluene, and I know that that's going to be my solvent, I can divide by 1,000, and that gives me kilograms. So this is my solvent down here, um, already solved for. All right, so we have to get from grams to moles of our naphthalene here. So you would be able to calculate the molar mass. So carbon is 10 times 12.01 plus 8.08. Our molar mass for C10H8 would be 128.18 grams per mole. And you could find those values on the periodic table for carbon and hydrogen if you don't have them memorized. What we're going to do here is take 36.5 grams, divide by the molar mass, 128.18 grams per mole. That will become our value for moles, and that is about 0.285 moles. So I'm going to take that value, plug it in over here to my full equation. And now I have units of moles per kilogram. So I know that when I solve this, I'm going to find molality. And this turns out to be 0.671. And we could say molal instead of with molarity where we say molar. So 0.671 molal for sample exercise 5.